All right, everybody, how we doing? Here for the very first video lecture for the class. So we're starting out with chapter 1 and 2 here, which is titled Math in Chemistry. Now, if you did not know this, I might have mentioned it a little bit in the past, week or so since we started school, but chemistry is pretty math-based, right? I'd say about 40% of this class can sometimes be quite involved with math. So a good amount of this, again, is math. It's not always algebra, which I know algebra is not everybody's favorite thing to do, but there certainly is a good number of elements of math involved in this class. So we're going to kind of hash a majority of that out right now throughout chapters 1 and 2 here to kind of hit the ground running. So let's start out. Okay, let's just talk a little bit about the background of chemistry and what chemistry is, what scientists do, and how they go about doing their jobs, in this field of chemistry. So in order to do chemistry, scientists need a couple of things, right? They need data and measurements, which you guys actually all experienced in lab more recently. And of course, they need models. Now, what do each of those things mean? Data and measurements. First and foremost, scientists, they always are collecting data, right? Just like you guys did in the lab environment, they're always collecting data. Data are just basic pieces of information, and you can kind of break data down into a couple different things. Qualitative data being things like describing colors, describing odors, describing shapes, etc. Right? So, for example, I can take my my coffee mug here. I know I referenced this a couple of times. Take my coffee mug here, right? I can describe the color of this as being blue with a reddish kind of stripe here through the buffalo. The odor of it. Whereas the mug itself doesn't have an odor. If I kind of smell the general area around the mug, it kind of smells like coffee. But the shape of it is kind of cylindrical, right? You can almost say that the qualitative data is the quality of that particular object, right? The qualities of it. Uses your words, right? Your descriptors, it's like almost like you're in English class talking about a book you're reading, and the author is describing what something looks like in the book, right? Allowing you to use your imagination to think about that, right? On the flip side, completely opposite direction here for data is something called quantitative data, right? So there's qualitative data using words and descriptors, and now there's quantitative data. Quantitative data is almost exactly what it sounds, right? It's in the realm of quantities, right? So it tells you how much of something you have, how big something can be, and how fast something is, right? Using numbers, right? Using measurements more specifically here, okay? And I know I've talked about this a couple of times, especially in lab more recently, where I've said measurements are really important. They consist of two things, right? Measurements consist of a number and a digit, right? And it's really huge that you all know that and understand that, because you really truly can't have one without the other, right? Measurements are incredibly important in the world of science, and not even just the chemistry class or chemistry in general. Measurements are massive in general, and so making sure to recognize that they are numbers plus units is very, very, very important. Now, let's look at a couple of different types of measurements that are utilized in our classroom here. We've got 3 different columns here with this table. We've got quantity on the left, what it measures in the middle, and then base unit on the right-hand side. Base unit being like the most consistently used unit, the most commonly used unit based on that quantity, okay? So starting out here with length, okay? Of course, what length measures is how something long is, right? So oftentimes, if you're using a meter stick or a metric ruler, you're using that to help you determine how long something is, right? And the base unit for length here is going to be meters, which is using a cap or a lowercase m for its measurement. Next up, of course, is mass. And what mass measures is weight. You guys had some experience utilizing a piece of equipment in the lab environment, utilizing a way to measure mass here, which is going to be your triple beam balance. It helps measure weight, and its base unit, which you guys had some experience with, was grams, lowercase g for grams. Next up here is volume. Volume is based on how much space something takes up. Right? I know oftentimes volume is utilized to help measure an amount of liquid, and it is, but it's also a great measurement to help you determine how much space something takes up, right? Because you can kind of have the volume of a shape, the volume of a room, for example. And although you're not dealing with liquids, you're still talking volume. So it's really truly how much space something takes up. And oftentimes we're utilizing the base unit of liters, which is a capital L. Sometimes on the other side too, you're also utilizing your ml or your milliliters. Next up here is temperature. Okay, temperature is the next quantity, and what it measures is not similar. It's not quite what you might be thinking, right? When you guys think of temperature, you think of the whatever you see on your phone, right? Whenever you look up the temperature, maybe it's a nice fall day and you want to make sure it's not going to rain, and you're checking the weather app to make sure it's not going to rain. You're checking the weather app to see what temperature it's going to be and whatnot. Temperature is not just that number you see in your phone or the number you see in your thermostat or the number you see whenever you use a thermometer, for example, right? It truly measures something called average kinetic energy. We're going to talk more about that as we actually progress into chapter 3, but we're going to hold off for right now talking too much about that. Now, the base units for temperature are going to be 2 in specific. Kelvin, which is a capital K, and the Celsius, which is something you've probably heard more commonly from our neighbors in the north there in Canada, degrees Celsius, right? The little degree symbol there with a capital C. We'll talk more about Kelvin sometime soon. And last but certainly not least is going to be time, right? Of course, have to mention time. Can't talk about measurements without talking about time. Time is a quantity, but also just straight up measures time as well. So time is a quantity, and what time measures is time. Now, the base unit for time is going to be seconds, not minutes or hours or anything like that, or even days. It's definitely going to just be seconds, right? So it's the easiest one to kind of understand. Now, bringing it back a little bit, what do chemists do with all this information, right? What do they do with all these measurements and this data, this quantitative data, the qualitative data, all that good stuff, right? They use these things. They take these measurements from the data they collect and develop models to explain what these measurements mean. And they test those models according to the scientific method. I'm sure you guys have all heard a lot about the scientific method. Okay, so under that realm of the scientific method, they take those tests, or they take those models and they test them according to the scientific method. Then, when they do those tests through the scientific method, they can come up with some pretty great conclusions, or sometimes not, right? Sometimes their conclusions are all not that conclusive. But that's okay, right? Chemistry in the world of science is all about trial and error, right? So conclusions become the new models used to understand new measurements, right? So in general, I've been using this word model a few times here. Models are pretty straightforward. They're visual, verbal, or mathematical explanations of experimental data. So oftentimes when you guys are in the lab environment and you're writing out on for example, right, you guys, this should all look familiar, right? This is your density of unknown data table. That right there is a model, right? You guys are categorizing data into a nice, concise table. That's a model. When you guys are completing and taking the steps to complete your, your lab write-ups, for example, right? All of that information you're kind of putting together in that lab write-up is a model. You are explaining your data that you collected when you're in the lab environment and putting it together in a nice and neat fashion. That is a model, right? So without even realizing it, you guys have already put together a couple different models. So it's pretty simple to do, and it's something that chemists do often, okay? Now, talking more so specifically about lab, and something that we touched on in both labs 1 and 2 here is density, right? Density was a very core principle surrounding our lab. So let's talk about mass and volume. Now, mass is the number or the amount of matter something contains. Matter is anything that has mass and takes up space, and volume is the amount of space something takes up. So the way I like to kind of describe these things, specifically matter, is that matter is basically 2 things. It's mass plus volume, because of course matter is anything that has mass, so there's mass, and takes up space. Well, if you look at the definition of volume, volume is the amount of space something takes up. So if matter is mass and takes up space, well, there you go. Matter plus volume equals, or mass plus volume equals matter. Okay, so matter, again, consists of 2 main things, mass and volume. Now, whenever you have a discussion about mass and volume, density always becomes the next topic, right? Because density is the measurement of how much mass you have given the amount of volume or space that you have, right? So if you look at these two diagrams here, we've got two cubes with a bunch of red spheres kind of packed into them. Now, if you look, hopefully you're able to, figure out that looking at both of these different cubes here, they're the same size, right? These cubes are very much the same volume, the same size. There's not much difference between the two different cubes here in terms of their size, how big or small they are. So two cubes, same exact size. Now, although the volume, so when I say the same size, I mean the same volume, they have the same volume here, the contents packed inside of that space, packed inside of that volume of those squares here are very, very, very different, right? Each one of those red spheres consists of the amount of mass inside of that particular cube there. So, of course, on the left-hand side, we've got a cube that has a substantially more amount of red spheres here, which is going to lead to a higher mass, so therefore a higher density, right? More dense. Now, the cube on the right has significantly less of those red spheres, so therefore it has a lower mass and therefore a lower density, okay? So that's kind of a descriptor and two different models to show you the difference between density and comparing that with matter, or comparing that with mass and volume. Of course, something you guys have most likely worked with in the past here is the equation for density, and it's one you guys have obviously seen more recently in the lab when you're doing your lab write-up for 1 and 2. Again, you might have utilized the density formula in the past as well, but density equals mass divided by volume, right? D equals M over V. So this is your density formula. Again, it's one that you guys are going to be utilizing in your lab for labs number 1 and 2. And when I see you guys next in class, we're going to be working with this formula to do a couple of different examples in class. Okay. Thanks very much, and I'll see you in the next one.